So last class we had discussed about what is replication controller and what is replica set and what is difference between replication controller and replica set. Today we'll see that combination and all. Okay. So replication set and replication controller both purpose is same only. It is maintaining pod life cycle. Replication controller and replica set both are maintaining pod life cycle. So managing the pod life cycle and even that pod is crashed and the pod is deleted automatically, the replication controller will replace it. The only one thing is a replication controller, it is supporting a equality based but a replication set support set based selector. There is a one more match labels and we are giving a match labels, we are giving some name and so there is a match label, match expressions key and operators in value equal to environment, which environment you want. So this is the extra, these are the extra. There is a match expressions key equal to which environment env and operator in values equal to I want to execute only dev environment. So if you want to execute that case, remaining both are same only. Both are same only. Apart from this, nothing. All are same only. Only this is the extra things. Now this is the demand set. Demand set is nothing but right. Mostly interview also most of the people they are asking what is demand set. DAEMON demand. So demand set means this is mostly this is also one Kubernetes resource and demand set ensures all nodes run a copy of pod. If you go here, if you go here, so for example, just assume. So this is my pods. This is my pod. Right? So this is the one pod. This is the one pod, and this is the one pod. I have multiple pods, and every node. So just assume in every node, I have to maintain one pod. So by default, these pods are created by us, right? So for example, this is the worker node one. I created one pod. This is the worker node one. Or come to here. This is right. This is the master, and this is the worker node. Just assume these are the two worker nodes. Now you know what is master. How these are connecting here. So if we create any pod, so it is running here only. This is the worker node. This is the worker node. Every worker node, we have to run one pod. We have to run one pod. This is the worker node 2. This is the worker node 2. This is the master server. This is the master. This is the Kubernetes master. Now, if you create any pod, just assume here it is running one pod. I created one pod. For example, Java Maven web application, I run one pod. Now, there is a one more object is there. This is the daemon set object. Daemon set object means in every node it is maintaining one pod. So what is the purpose? Why you need to, for example, this is the daemon set object and this is also daemon set object. Just assume I have two nodes and every node, if I run one daemon set object, and every node, it is creating one pod. It is creating one pod. So what is this main purpose? See here, a node are added to the cluster, pods are added to them. For example, I created daemon set object. I created daemon set object. So I created daemon set object. The daemon set. I created daemon set object, and every worker node it is creating one pod. Suppose if I add one more pod, so automatically it will create one pod here also. Automatically it will create one daemon set object pod also here on a pod. This is the behavior of daemon set object. Suppose if we destroy the node, for example, I deleted this worker node. I removed this worker node. So what about this pod, demand set pod? Automatically it is go to garbage collector. That is the see here, pod are added to them, a node are removed from the cluster. Just assume I removed from the cluster. This node I removed from the cluster. Automatically cluster deleting the demand set will be clean up and pods will be recreated. See? So pods are garbage collector. Automatically the pods go to garbage collector. If you remove from the any node, as nodes are removed from the cluster, those pods are garbage collected. Deleted demand set will be clean up the pods is created. Clean up the pods is created. This is the main purpose is running a cluster storage on every node. I want to check some storage, or I want to check some logs, or I want to monitoring my worker nodes. So that case mostly we go for demand set object. Very. So now these are the nodes, right? I want to monitor. I want to check logs. That case mostly we go for demand set object. So if you want to check the logs, I want to get logs, or I want to monitor my worker nodes, monitoring my worker nodes, or I want to usage, CPU usage. See here, that is the every node storage. I want to monitor my storage. No, these are the common things, right? All worker nodes. So suppose if you want to monitor your logs, all worker nodes, or if you want to monitor storage and whatever it may be, some common functionality. So that case mostly we go for demand set object. Mostly we go for demand set. Demand set make sure all or some Kubernetes nodes run on copy of pod. Every worker node it is running one copy of pod. So when a new node is added to the cluster, pod is added to it match the rest of nodes. When the node is removed from the cluster, pod is go to garbage collector. So that is the behavior. That is the behavior of demand set object. I hope you got it right. See, if you create any node, if you add any node to cluster, automatically the demand set pod will create in the node. So this is some common functionality. All worker nodes, I want to check storage. All worker nodes, I want to see logs and all. All worker nodes, I want to monitoring. So that case mostly we go for demand set object. Suppose if you remove any node from the cluster, automatically this pod will go to garbage collector. If you add any worker node to cluster, automatically that pod will add to that cluster, that worker node also. So that is the very simple. That's it. Apart from this, nothing. If you understand this thing, let's see. Here also they are same thing. They are explaining. So why you go for demand set object? So if you want to storage, running cluster storage demand every node, or if you want to running logs collection demand on every node, or if you want to running node monitoring demand on the every node. I want to monitoring, I want to check the logs, I want to check the status of my storage and all. So some of a common functionality. So that case we go for demand set object. Clear? So I want to get logs all worker node, I want to get I want to check the storage from the all worker every node, and also I want to monitoring my worker every node. So that case we go for demand set object. So this is the syntax. Remaining story same only. Only kind equal to demand set. Only kind equal to demand set. We need to give remaining everything same only. Remaining everything same only. So how it will work? This is the demand set object. This is the demand set object. See here, kind equal to demand set, and here also we are using nginx selector match label nginx template metadata name labels and node. So see here, this is a spec node selector. Right now we don't know, leave this one node selector and all. This is a containerization. This is a container name nginx port and all. Only we have to give kind equal to demand set. Kind equal to demand set, kind equal to demand set. Suppose if you want to specifically run that case node selector, we need to give that node name. Remaining all are same only. Okay, we'll see. Now very important object. So deployment object. So most of the cases we are using deployment object. So deployment as of now, right? We created multiple parts. Right? How to create pod, how to create service object, how to create namespace, and how to create replication controller, how to create replicas set. All. So as of now, you know how to create pod and RS, replica set, RC, replication controller, namespace, NS, you know. Now we know what is this daemon, daemon set and all. That is very, very important. Deployment, all are objects only, deployment object. So if you want to create pod, we can use anyone, you know, right? So whether we can use this one, we can whether use this one, or we can use replication controller, replica set, we can use anything. But why you go for deployment object? There is an extra features available. So if you use only pod, we cannot scale up, we cannot scale down, right? And if you use replica set and if you use replication controller, so there is a one tag replica set. So there is a one tag, right? So this is the there is a one tag. With the help of the tag, so we can set. See here, there is a replicas. How many replicas? Who will maintain? This is maintained by replication controller or replication set. So this is the pod life cycle. So the pod managed by replicate pods and all. It is way the managing the pod life cycle. So who is responsible? Replication controller or replica set. Now with the help of pod also we can create pod. With the help of replication set also we can create pods. With the help of replication controller also we can create pod. And why you go for deployment object? Now see here, if you use, we cannot scale up, we cannot scale down. And with the help of, we can easily scale up and we can easily scale down. Now this is the deployment object. So this is the main object in so Kubernetes, and this is also one Kubernetes object. See here, Kubernetes deployment is the recommended way to deploy your pods. Recommended way. So if you want to create any pod, if you want to create any pod, which is the recommended object in Kubernetes, deployment object. Now we'll see what is the purpose and all deployment object. So this is the main object, deployment object, declarative objects and all. So describes the desired state to in deployment, and the deployment controller changes the casual state to desired state and control the rate also. So rate use cases. Create the deployment to roll out the replica set. Declare new state of the pods wherever you want. Next, roll back to earlier deployment version. So these features as of now you don't know. We can create pod with the help of pod object. We can create pod with the help of replication set. We can create pod with the help of replication controller also. But why you go for deployment object? So these are the extra features. See here, rollout replica set. So the replica set create pod in the background. Check the status of the rollout to see the success or whether it is failed. So with the help of deployment object, we can check that status of the pod, whether that pod is success or not. And also declare new state of the pods by updating the pod template spec of the deployment. The replica set is the created and deployment manager moving the new pod and all. And if you want to roll back, see here, for example, I deployed one pod. The pod is not working. That is failed. There is some problem. There is some problem on pod. So it is unable to create. Keep on recreating and keep on recreating. And that case, so this is the rollout. This is the roll back to the earlier deployment and scale up the deployment to failure mode scale up deployment. If you want to we can scale up, or if you want to we can scale down. And there is one more, if you don't want we can pass the deployment. See here, multiple fixes to the its pod template spec, then resume it start a new rollout. If you want to we can pass out also. See here, use the status of the deployment, we can check whether that is indicate the rollback has struck or not. And clean up older replica set. If you don't want, we can delete, we can clean up the older replica set also, replication controller and replica set. So these are the extra features compared to pod, compared to replica set, compared to replication controller. So what is the main advantage of deployment? So these are the main advantage of deployment object. See here. So deployment is the recommended way to deploy your pods and replica set because of the advanced features. See here, deploy in the replication set and update the pods. If you want to, we can easily update the pods. And if you want to, we can roll back to older deployment version. For example, I deployed one version. We can, if you want to, we can roll back to older deployment. And if you want to we can scale up and we can scale down, you know, right? Here I given replicas. For example, here we are giving that count. So if you go here I am giving replicas. Replicas, I given five replicas. Whenever if you want, we can directly scale up, and if you want, we can scale down. I want to increase 10, we can increase to 10. If I don't want a 10, 5, if you want to, we can decrease with 3 also. So this and all replication easily we can possible with the help of deployment object. With the help of deployment object, see here, roll back to older deployment version and scale deployment up and down, right? This is if you want to, we can scale up 10, if you want to scale down 3. So that case also we can use. Now pass and resume the deployment. Pass and resume the deployment. So if you want to, we can pass when a particular time period I don't want to run, so we can use pass. Pass or resume, or right, pass means we can hold on some time. So if you want to, we can resume also. We can, if you want to, we can resume the deployment. Now use the status of the deployment to determine state of the replicas. We can check whether the deployment has done perfectly or not, whether successful or not, we can check it. Now if you want to older replica set, I don't want to, I created many replica set, so those are unused, that is space waste, right? Memory waste, space waste. So that case you should go for, we can easily scale, we can easily clean up, we can easily clean up. You don't want, we can remove all these things. So these are the these are the extra features compared to other objects. I hope clear, guys. Anyone any doubt here? Deployment object is the recommended way to create the pod. Deployment object is the recommended way to create the pod. So with the help of pod, we can create pod. With the help of replication set also, we can create pod. With the help of replication controller also, we can create pod. But what is the main advantages? Why you need to, why we go for, why you need to go for deployment object? So we can easily scale up, we can easily scale down, and we can roll back it, and unused parts and all we can usually clean up, right? So these are the some of the advantages. Roll back, scale up, scale down. If you want to, we can pass, resume, and update parts also, and deploy the replication. Okay, so these are the commands. See here, kubectl, scale, deployment problem, replicas, how many you want. Okay, now we'll see practically how it will work. We'll see practically how it will work. Now interval also, this is very very important. This is the very very important deployment strategies. There is two ways here we are following deployment strategies: rolling deployment, recreate deployment. This is a rolling and recreate. So these are the two types of deployment strategies we are following in Kubernetes. If you are using rolling, right? So rolling update, or recreate recreate. These are the deployment types. We are following a deployment strategy in Kubernetes. We are following, so one is recreate and is rolling deployment. So this is the rolling deployment. So rolling deployment, recreate, rolling deployment. Now got it? So what is this? This is eraser. This is eraser. Okay. So we, it is not going. Okay. So we can follow. So two types of deployment. One is rolling. Right? What is rolling means? Roll. Rolling means moving. This is rolling deployment. Recreate. Just we need to remember this, create. These two words only. Rolling and recreate. Now, if you see here, what is rolling means? For example, I created one pod. Meantime, let me run my cluster also. Meantime, let me run my cluster. We'll see practically how it will work. Okay. Now, so now if you go here, rolling deployment is the standard default deployment in Kubernetes. Suppose if you are not mentioning anything, which is the default one? Rolling deployment. Which is the default one? Rolling deployment. Rolling deployment is the standard deployment, standard default deployment to Kubernetes. It works slowly one by one, replacing part of the previous version of the application. So if you understand, so this is my pod. This is my pod. This is my new pod. This is a old. This is a new pod. So how it will work? Just try to understand. So how it will work means, just assume this is the version. So just a version V1. This is the version V2, new version. So this is the V2. This is the V2. This is the V1. This is the older version. This is the new version. Now, if you are using rolling, if you are using so rolling deployment, this is the default one. This is the default deployment. This is the default deployment. This is the default deployment, rolling deployment. So just assume this is the running pod, running application. Nothing, no errors, everything working fine. So this is the container one. This is my app, everything working fine. So everything working fine. There is no issues. And they migrated something. They implemented new things. This is the updated, this is the enhancement, new features. So new features in the application, new features in the application. Now if we see here, see how it will work means, so the rolling see the rolling deployment standard default, it works slowly one by one, replacing parts of the previous version of your application with the pod of new version without any cluster downtime, the rolling update waits for new pod to become ready before it starts scaling down the older one. When it is going to down, this is a new version, right? I deployed new version. This is the old version, it is running. So now if it is working fine, if everything ready, so this pod is ready. Now then only the older pod going to destroy, the older code going to remove. Suppose if it is not ready, it is not going to remove anything. See here, new pod become ready before it starts scaling down the older one. If there is problem, the rolling update deployment can be aborted without bringing the whole cluster down. So in the YAML file we are mentioning, see here, this is the this is the this is the process. If version 2 is ready, version 1 is going to, so we are going to delete. So down, we are going to make it down one by one, slowly, one by one. If it is ready, so then only. So suppose if we have two parts, directly it won't remove two parts at a time. So this is the two. This is one more part. This is a new version. So once this new version is ready, if everything is ready, see here. So become start scrolling down older one. So become the ready before starts scaling down. So if it is ready only, then slowly we are removing the older one. Slowly we are going to remove the older one. Got it? So that is the behavior of rolling. Rolling. Okay. Rolling means if a new pod is ready, we are going to down older pod. Otherwise, we are not going to down. So this is the one. This is the rolling deployment one by one. Now there is one more deployment, recreate. Recreate means in this type of very simple deployment, all older parts killed at a time and get replaced by new parts. 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 Now got it. So this is the recreate. Recreate means in this case. So just assume this is the recreate. If it is a recreate, this is a V1. This is the V1. This is the recreate. Now in this case, this is the recreate. Re, this is the recreate. Recreate. In this case, assume this is the V1 older version, and this is the new version, newly created. Okay. Now if you deploy this one, immediately it is deleted this older one. It is killing that older part. This is the old, this is the new. If you deploy new version, so automatically see here, all in this type of simple deployment, all of the old parts killed all at once and get replaced all at once in the new one. See here, there is no time. So the previous one, if new is up, then only we are going to delete older one. If new is not up, we are not going to delete older one. But in this case, we are not going to give any grace period. See here, immediately we are deploying, immediately we are deleting older parts once a new part is deployed. So this is the very simple. Old parts are killed all at once and get replaced all once with the new ones. New ones. That is the recreate. That is the recreate. Anyone, any doubt here? So there is two types of deployment strategies we are following. In Kubernetes, we are following two type of deployment strategies. One is which one? One is recreate, and the second one is recreate, and the second one is recreate, and the second one is this is the recreate, and the second one is first one, right? First one is rolling. First one is rolling deployment. Second one is recreate deployment. Recreate to deployment. That's it. Interval also very important. Just remember, rolling means once new pod is ready, older parts we are going to remove. Recreate means we are not bothering anything. Once deploy new pod, immediately it is deleting older parts. That's it. That is the very simple only. We need to understand how it will work. Now let's come to practically how it will work. Now see here. Now this is ready. Now my both are ready. Now go to here and go to where is my path. Every day I'm keeping somewhere. Go to here. C column users HP practically this one. Okay. Now so deployment rolling update recreate. Okay, copy. Go to here, pasting here. Okay. Now go to here. Now control plus plus. Okay. 1 second. Note back. Note back. Deployment. 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 I am using first test. Deploy test dot wiper. Now if we see here, only see here kind equal to deployment. This is the kind equal to deployment, and we can give any name. And the replicas I given two. Two means how many parts it will create? 2 means how many parts it will create? 2 parts. Replicas 2 means 2 parts. And selector, match label, and template. This is the this is the part information. Metadata labels my container app. This is my version. This is my current version. Just assume 200. This is my current version 200. And this is, I hope everyone know, kind equal to service metadata, and so type equal to, here I am using load balancer, and selector, see here app colon app, same name we need to maintain here also. You know, right, what is service object, how this service object discoverable particular pod. So port number 80, and this 8080 match with the container port number, target port match with the container port number. This is a ports, this is a ports, container ports, port and all. Okay. Now, so this is nothing, same. Here we are using replica set, here we are using replication controller, same only. Here extra only we are maintaining. Here this is the image. I am using a version number 200, right? Now let me create how it will work. Now go to here. So before that, kubectl, delete all hyphen all. I am going to delete existing all. CLS kubectl get parts. Okay, no namespaces. Now how to run my file, configuration file? How to run my kubectl? Apply -f, deploy, hyphen f deploy test. Deploy test. Now see here. So deployment object created and also service object also created. Now we know how to check CLS kubectl kubectl get pods. How many parts? Two parts. See here. How many I given? Replication count. Replicas equal to 2 I given. Two are running. Two are running. Now see here. Kubectl get SVC service object. Now see here. This is the load balancer. This is the local host. And with the help of this external IP, we can access. Now same way kubectl 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 get all. If you use get all, so here it is created replica set or replication controller. Now observe here. So I created deployment object. I created deployment object. So automatically replica set also created. Now observe here. Here we can check it. Desired state, current state, ready state. What is the purpose of replica set? Replica set main purpose is handling the pod life cycle. Already you know. What is the main purpose of the replication set? The main purpose is it is handling the pod, managing the pod life cycle. Who will take care? Pods and all. Who will take care? Parts and all replica set only. Replica set only. If we create a deployment object, by default it is handling. See here replica set. Replica set it is handling the your deployment object. Your deployment object. See how many desired, how many parts you want. What is the current? What is the ready parts? So age is 37. Anyone any doubt guys here? See here CLS and so kubectl, 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 kubectl describe get svc and so kubectl get kubectl describe describe and service name my app hyphen svc hyphen svc kubectl anything doesn't have resource type my app hyphen correct one right, copy this one kubectl describe describe and object name. Sorry, svc right, we missed svc service right, kubectl svc and service name. Okay, now if you observe here, see here endpoints 10 dot 1 dot 1 dot, this is the one pod, this is the one pod. Now this is here namespace default only, type equal to load balancer, and this is the IP of your cluster, and this is the target port number 8080 and node port number 30. This is the endpoints. Now if you observe here two IPs, right? What is this two IPs? What is this two IPs? kubectl, kubectl, kubectl get parts. Now see here, these are the two parts. If you want to know more about hyphen o wide, hyphen o wide, we can see some more. See here, I want to know some more columns. I want to get some more columns regarding this pod information. So earlier I am getting only 3 4 columns, right? Name, ready, status, restart age. Same name, ready, status, restart age, and also I am getting IP. What is the IP of this pod? 10.1.0.106. And what is this IP of this pod? 10.1.1.107. 107. This is a node. So here my all are here. I am using a Docker desktop, right? So all pods running same missions only. So only all are running same missions only. So generally here it is coming a different node name. Here it is coming a different node name. But in my software here we are using Docker desktop, right? All are running same only. All are running same only. Now check it. How to check my application is running or not? Now see here CLS kubectl kubectl get svc. Okay, now this is the local host. Copy local host, go to browser, Just paste it. Localhost, right? Localhost. Now see here, your application is working or not? Application. So coming slash maven hyphen web hyphen application. This is my context path. Which name I given? My context path maven, which is this my context file. I forgot that. Mm, 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 mm. What is my context path? My application. I think I given same only. I don't know. Maven hyphen web app or application. Not request is not available. Okay. Anyway, we need so this context path. If you configure this channel right now, we didn't configure it. We are unable to log in. We are unable to log in. Okay. So we need to add this users and all particular contact. So now if you use your context path, so automatically we can access your application. So if you use your context path, now this is the root URL. This is the root URL. In this application, here I given some application name. Let me check what is that one. Notepad, Notepad, deploy test hyphen, which is I think Maven new application. I don't know. Just I'm searching for. We need to give this contact path. Maybe I given same thing or not. This is not also correct. Web hyphen app. This is also no. Okay, I will check other image or we can change it. We'll check it. Or come to here, you know, right? hub.docker.com. Hub.docker.com, and we can use a different anything. We have many images, right? We can use anything. Edit. Let me check another image. Mm, okay, here we are using this one, right? Maven web application, and we can use June Maven web application. What is the tag? Also here using tag one. Okay, Maven web application tag one. We can update. Go to here. I'm using tag equal to one. Tag equal to one. Tag equal to one. Okay. All five. Save. Here only one application is there. Or else we'll see. I will show you first. We'll see that logs and all we can easily understand. Now any parts are running. CLS kubectl get parts. Now if you kubectl get the parts. Now there is one version is running. So what is that version? I want to check it. Now see here. So if you want to see, so there is a one command deployment object. See here, I want to check. I want to increase the parts. Right now, how many parts here it is running? Two parts. I want to scale up. This is the command kubectl scale kubectl scale, kubectl scale. This is the syntax. Kubectl scale, deployment and deployment name. What is the deployment name? First check it. So kubectl get all. So this is my deployment name. This is my deployment name. Okay. Now kubectl scale, kubectl scale, deployment name, deployment name, deployment and deployment name. This is my name. So paste it. And next hyphen replicas. See here, hyphen replicas, number of replicas. See here, replicas. I am giving 4. Now got it. See here, kubectl scale, deployment and deployment name and hyphen replicas. How many parts you want? I am increasing. That is scale up. Now see here, I am scaling up. Now see here, it is the deployment scaled. Now earlier we can see 2 parts, right? Only we can see 2 parts. Now we can see 4 parts. Now check it. Kubectl get all. Kubectl get all. Now see how many parts we can see? 4 parts. This is a scale up or scale down? Scale up. Again, I don't want this many parts. I want to scale down. Same command. Kubectl, kubectl, scale, deployment, deployment, deployment name. What is deployment? My app dep replicas. I don't want 4. I don't want 4. I need only one part enough. Now I'm giving C here. So this is scale down. I am using scale down 1. Now see here, kubectl kubectl get all. Now we can see only one part. Now we can see only one part. Now see, so if you want to scale up, we can scale up. If you want to scale down, we can scale down. So this is the one of the feature in deployment object. This is the one of the feature in deployment object. Second one, suppose I want to see the history. I want to see the history. See here, kubectl rollout history deployment. Now what is the history, guys? Right now I deployed which version? 200, right? Now I'm going to modify same thing. I'm going to modify same thing. Kubectl notepad. Now this is the deployment. What is the file? Here I write. Here I'm going to use what is this version? Previous version. This one, right? What is this? Maven application. And here we have many versions tags. I need this one. Maven web application. Maven web application. Maven web application. Here I am using so 200 earlier using. I am using what is the tag I am going to use? R90 anything 201 201 201 201 file 201 control S save control S save file save close it. Now I am running a new version. Just assume. So this here it is running a 200 version. Now I deploy it to 201 kubectl apply hyphen f hyphen f hyphen f hyphen f deployment deployment test deployment test.yml. Now see here, this is unchanged, only configuration part is done. Now see here, kubectl clear the screen, kubectl get all. Now I have one pod. See here, I deployed new one. I deployed new one. So I deployed a new one. I deployed so new one. And so now check it. Now check it. History, right? What is the command? So kubectl rollout history deployment name deployment name kubectl roll out history deployment and deployment name. What is my deployment name? My app-dep. My app-dep. See here. So previous one version is there, revision number. This is the new version. See here, we can see history also. This is the command kubectl rollout history, kubectl rollout history, kubectl rollout history, deployment and deployment name. Now we can see here. Now we can see here revision numbers. Now we can see here. Now I am going to change one more version also. Now I am going to change one more version also. Now I am going to just update. See here. Now I am going to use 99 tag number. This is the old version 199 198. I want to deploy older version. Now file, save, file, save, and again I am going to execute. Now see here kubectl apply kubectl kubectl apply -f deployment 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 -test deployment -test. I changed. Now same command. I want to see history. I want to see history. See here kubectl 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 what is command? Roll out history. Roll out history. I want to see history. Deployment name. My a what is this? Get all kubectl roll out history deployment name. What is my deployment name? My app hyphen dep. My my app app dep. Now see here. So now we can see that revisions also. Now one more command. Same. Now, for example, I want to go to, now I want to see the status of the deployment. Now see here, kubectl rollout status deployment name, rollout status. If you want to see status also, see here, kubectl, kubectl, kubectl rollout status, roll out status, deployment status, rollout status, deployment and deployment name my app-dep my app-dep. Now see here earlier version so success or failed. Now I'm going to wantedly failed. I'm going to do wantedly failed the deployment. So now see here kubectl notepad. First I'm going to edit my file. Notepad deployment -test. Okay. Now here I am going to update so extra 18. Actually this tag number not available in my version. I am giving 1988. I am extra added. This tag not available in my hub. This tag is not available in my hub. See, save. Now rerun it. kubectl 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 apply -f and so deploy -test -test. Now this is the configure. Now I want to check the status. Now see here kubectl rollout status deployment name. Now see here failed. See waiting for deployment rollout to finish. 1 out of 2 new replicas have been updated. It is failing. Still not at deployed successfully because that tag number is not available in my repo. My tag number is not available in my repo. Now got it. Now see here, keep on it is waiting. It is not succeeded. Earlier if you see here it is success. Earlier if you see it is success. Now I updated my configuration file. I given wrong version number. I given wrong version number. Now I am seeing the status. kubectl rollout status deployment name. Now got it. See here kubectl get parts. See parts. See here it is error pulling image error image pull. See here error image pull. What is this meaning? This is the one error. In real time also we are getting same error. If you get anywhere this error, what is the meaning? That tag version, that tag number, that version number is not available properly. Now how to check this status? How to check whether this status is success or not? How to check this status is success or not? This is the command kubectl roll out kubectl roll out kubectl kubectl roll out kubectl roll out status status, deployment and deployment name. My app -dep. Now see here, this is the problem. This is the problem. I hope you got it right. So like this, we can check all these things. We can check all these things. Now, if you want to get already, what is this, how to, check the deployment, get deployment, if you want to update the image also, we can update. And if you want to go to that particular version, we can use a two revision undo. If you want to go to undo version, so that case we can check here. That case we can check this command. So this is the undo deployment version. Now see here, write status, write status, control C, kubectl, rollout status, deployment, kubectl. I want to see all history, kubectl, rollout history. Now these are the versions. Now I don't want this version. I want to go to second version. I want to go to second version. If you want to go to this second version, this is a command. -2 revision, rollout undo. See here, kubectl, 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 roll out undo deployment, rollout deployment and deployment name, rollout under deployment name, my app -dep hyphen 2 revision. See here, this is a command, -2 revision, revision equal to which revision you want to go. I want to move the second revision. Okay, now I am using 2. Now got it. See here, kubectl reload under deployment name -2 revision 2. Now see here, roll backed. Now check the status, kubectl, kubectl, kubectl rollout status deployment. Now see here, deployment is success. Now deployment is success. Now deployment is success. Now deployment is success. I hope you got it right. So if you want to go to previous version, so this is a command, kubectl, kubectl rollout under rollout under deployment name -2 revision, the particular version name, that is tag name. So these are the features, these are the extra features in deployment object. So remaining all are same only, clear guys? So very very important. Please try to practice. Without practice, we cannot remember all these things. In interview also, most of the people they are asking. Okay, so how to roll out, how to see the history, how to see the rollout history, how to undo deploy under previous version. So these are the some of the basic commands. Deployment object basic commands. Okay, so that's it from my side. And today we'll see continuation tomorrow. Sorry.